Hello students, welcome back to my YouTube channel. This is Kashima Soni and today we are going to start another acid derivative, that is acid anhydride. Earlier we have taken the video of your acid chloride. We have discussed its physical properties and chemical properties as well. Now we are going to take up the acid anhydride. So before jumping to this topic, I would like to make a request to you. If you have not seen any of the previous videos in your carboxylic acid derivatives series, I'll mention the link. Go over there, check that first wisely and then come to this section. Okay, only then you will get the better understanding of the topic. Correct? So proceeding further is what we have the topics to be covered. Okay, so we'll be taking the introductory portion and then nomenclature of acid anhydrides. Then we'll be discussing the preparation part and then we'll be taking up physical properties and chemical properties. So we'll try to make it shorter as much as possible. So what I will try to do is to cover up the topic till here, your physical properties, and then I'll be taking up the chemical properties in another video. Okay, so yeah, let's see what is in the introduction part. See, your acid anhydride, they may be considered to be derived by the removal of a molecule of water either from two molecules of same acid or one molecule each of two different acid. कहने का क्या मतलब है कि जो आपके एसिड अनहाइड्राइड होते हैं ये किस तरह से बनते हैं आपके पास by the removal of a molecule of water. Okay, you can see the reaction over here. These are the two molecules of your same carboxylic acid. It could be same or different as well. Okay, so where R and R dash may be same or different alkyl or aryl group. Get it? So this is your reaction. By dehydration, you are getting your anhydride as a product over here. Correct. So your acid anhydride, see, it could be simple. That means it could be symmetrical like this, where your both of the alkyl group or aryl group are same, or mixed or unsymmetrical like this, where one of the alkyl group is different from the other one. Okay, so that is how you will categorize your acid anhydride into two parts, that is your symmetrical and unsymmetrical acid anhydrides. So next topic is our nomenclature of acid anhydride. Okay, see what is happening. All you have to do is to replace acid in your any of the acid term. For example, if it is acetic acid, you have to replace acid with anhydride. That's it. Okay, see, this is your acetic anhydride like that. You can see the structure over here, and in place of your acid, when you will get your product after removal of a water molecule from two molecule of your acetic acid like this, after removal of a water molecule, you will get this product. Okay, your acetic anhydride. Correct? Understanding? So this is how you are going to name your acetic acid anhydrides. Correct? So you can see all of these examples. Okay, next is in case of mixed anhydride, the name of two parent acids are written in the alphabetical order. Getting that? For example, if one is your acetic acid and another is your propionic acid, so alphabetically your A is going to get preference over P. Getting that? So which is why you will be writing acetic before propionic. Getting that? One is your R and another one, this group is R dash. Both of these are different. So which is why they are mixed anhydride. Okay. Now in the case of symmetrical anhydride, what is happening? You have to add prefix bis to the name indicating two identical acyl groups are present. This is what you have to show. See in the last case over here, see this example. This is the example of your bis chloroacetic anhydride. See why we have used the term bis, because you are trying to show that you have two same acyl group present over here. That is why you use the term bis. Correct? So this is how you are going to do the nomenclature of your acid anhydride. There are not so much of rules about the same, but let me conclude it for you once again. See, first thing you have to remove acid with anhydride. That is one thing. That is first rule. In second case, what you have to see in case of your mixed anhydride, you have to arrange the name as per alphabetical order. Okay, that is the second example that we have taken. You can see the second example, this one. Okay, then in case of symmetrical anhydride, what you have to do is to add prefix bis so as to indicate that you have two identical acyl group present in your given acid anhydride. Getting that? So this is all about nomenclature. Okay, so we are going to see the preparations of anhydride, and we are going to see the three different methods from carboxylic acid, from acid chloride and carboxylic acid salt, acids or their salts. Then we have manufacture of particularly acetic anhydride. That is quite important. Okay, so proceeding further. First is our from carboxylic acid. See, what is happening over here is simple acidic anhydride. They can be prepared or obtained by heating your carboxylic acid with phosphorus pentoxide, that is P4O10. That is one case like this. They have taken two molecules of acetic acid, and in the presence of P4O10, that is your phosphorus pentoxide, they have heated this particular two molecules of carboxylic acid so as to get your acetic anhydride like that. Correct. So this is how you are going to get your acid anhydride from carboxylic acid. That is one case. Another cases have also been mentioned over here, where they have used the dehydrating agent in place of P4O10. They have used P2O5. So this is also the case over here. But most preferable is going to be this one. Okay. Proceeding further, the second step, that is from carboxylic acid salts, where you will get both your unsymmetrical and symmetrical acid anhydride by treating an acid chloride with a carboxylic acid like that in the presence of base pyridine. Same base over here you can write pyridine like that, and you will get your acid anhydride, and side product HCl is removed. I have taken example as well, where our acetyl chloride is reacting with acetic acid. Any of the carboxylic acid you can take, okay, in the presence of base like pyridine, and it is resulting in the formation of your, say, this one is your symmetrical anhydride. Why? Because at both of the sides they are having same of your acyl group, correct? So which is why it is your simple or symmetrical anhydride, correct? So this is one example. Okay. So there we have another example where that is a case of your unsymmetrical anhydride, where you have seen the reaction of your acetyl chloride with sodium propionate. That is your sodium salt of carboxylic acid, which is used in place of free acid. So this will help you to get your unsymmetrical anhydrides like that. Okay, because this group is this much only, and this group is CH2, 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 CH3. Get it? Which is why it is unsymmetrical anhydride. Okay. So the very important method that we are going to take up, where we are just going to discuss about the manufacturing of acetic anhydride only. Okay. This is by far the most important acid anhydride synthesis by the action of acetic acid on ketene. See, what is ketene? This is the structure of ketene over here. Okay, you have to remember this particular structure, CH2 double bond C double bond O. That's all. That's quite easy, right? So what you have to do is to react your acetic acid, 1 mole of acetic acid with ketene, so as to get your acetic anhydride. Okay, we'll see the mechanism. Eventually we'll see the mechanism, but first you have to remember this thing, that acetic acid is reacting with ketene to give your acetic anhydride, that too symmetrical. Okay, you can see this one is symmetrical. So your ketene needed for this purpose, it is obtained by dehydration of acetic acid with AlPO4 at this much temperature, that is 1075 kelvins. Okay, so you can see dehydration is occurring over here. One hydrogen atom from this carbon and one hydroxyl group from this carbon is getting removed as water molecule, and you will get your required product, that is ketene. Okay, so you are getting ketene like that. So this is the mechanism you can see over here. See what is happening, nucleophilic attack by acetic acid is occurring. So your acetic acid is acting as a nucleophile over here, correct? It is acting as a nucleophile. Okay, correct. So that is one thing over here, that your acetic acid is acting as a nucleophile. Okay, so what is happening? Nucleophilic attack by your acetic acid on the electron deficient carbonyl carbon of ketene. How it is electron deficient? Because oxygen is accepting electron from this pi bond, correct? Which is making this carbon now susceptible to get attacked by the oxygen of your acetic acid, that is nucleophile. Okay. Getting that? Because now it is electron deficient, so it is quite susceptible to get attacked by your nucleophile. Understanding? So which is why it affords an addition product, which this is your addition product, which subsequently tautomerizes. This is your intermediate. This is your addition product, which subsequently tautomerizes to form your acidic anhydride. See what is happening up to here. It is clear. Okay. Nucleophilic attack is occurring via your acetic acid. It is acting as a nucleophile and it is attacking your this particular carbon over here, okay, which is resulting in intermediate like this. Now what is happening in the next step is occurring. See, your oxygen is electronegative in nature. It is trying to retain its electronegatiivity. Also there is occurring proton transfer. So what is happening, this proton will get shifted over here like this, you can see. Okay, so this is basically a step of your proton transfer, correct. Now what is happening, see, deprotonation and protonation is occurring at the same time. So basically this is called as proton transfer over here. Proton transfer. This step is particularly proton transfer. Now in the next step, what is happening? Tautomerism. See, this hydroxyl group will be getting turned like this as a C double bond O group. This is a sort of your tautomerization. Okay, what is happening if you have to open it like this? You can write it like that, and there is a deprotonation is also occurring, which is resulting in the formation of this particular step. So that is your tautomerism. Okay, that is all about this particular manufacturing of acid anhydride mechanism. Where in the first step, what is occurring? Nucleophilic attack, and this is the intermediate that you are getting. And in the next step, what is occurring? There is occurring the formation of addition product via proton transfer step. In the last step, what is occurring? Tautomerism, which result in your ultimate product, that is acetic anhydride. So that is all about the preparation. Now let's just talk about the three properties of your physical properties of your acid anhydride. First is your physical state, color and smell. See what is happening, that your lower aliphatic anhydride, they are colorless. Okay, remember that. Lower aliphatic anhydrides are colorless liquids with sharp and irritating smell. Okay, while your aromatic acid anhydride, they are colorless liquids. That is it. So what we have talked about over here is your lower aliphatic anhydride, they are colorless liquid as well as with this sharp irritating smell. While we are talking about aromatic acid anhydride, they are colorless liquids only. Okay, that is it. Now when we talk about boiling point, what is happening is your boiling point of acid anhydride are higher than those of acid. See, if you are going to compare the boiling point of any acid, for example, if you talk about acetic acid and acetic anhydride, so if they ask you which one of them is going to have a greater boiling point, so you should remember your acid anhydride is going to have a greater boiling point as compared to your acid, any of the acid, okay, than those of acid from which they are derived. This is due to the reason that the size of anhydride is much larger than that of parent acid. That is one reason. Okay, as a result, what is happening? They have stronger van der Waals forces of attraction, which account for their higher boiling point. That is the case of your anhydride, which is why they are going to have your higher size as compared to parent acid, which is why they are going to have a stronger van der Waals forces of attraction and ultimately higher boiling point. That is one thing. Unlike carboxylic acid, they do not form intermolecular hydrogen bonding. Okay, so that is about the boiling point. Third point is your solubility. They are actually generally soluble in common organic solvent, for example, in your ether and benzene. So these were the three physical properties of your acid anhydride. Quite easy to remember. There is nothing so difficult about it. So this much you can take up over here in this particular video. So yeah, that's all about it. And if you have any sort of queries, any thing that you have not understood, you can mention it in the comment section. And you must check all the links that is mentioned in the description box for your better understanding. So yeah, that's all about it. Thank you. Do like, subscribe my channel for more chemistry related videos. Thank you.